divide and conquer method. It is a strategy for solving a problem, or it is an approach for solving a problem, or we can say it is an algorithm design technique. There are many algorithm design techniques such as divide and conquer method, greedy method, dynamic programming, backtracking, brute force algorithm, branch and bound, etc. A divide and conquer algorithm works by recursively breaking down a problem into two or more subproblems of same or related type until these become simple enough to solve directly. The solution to the subproblems are then combined to give solution to the original problem. That is, if the problem is large, divide and conquer algorithm divides each subproblem until it is small. If the subproblems are small, then individually solve each subproblems and combine the result of each subproblem. That combined result is the result of the main problem. We cannot solve all the subproblems based on divide and conquer method because all subproblems should have the characteristics of main problem. Binary search in a sorted array is an example of divide and conquer. Here all the subproblems have the same characteristics. But binary search in an unsorted array. Here there are two types of subproblems. One is sorting and the other is searching. So their characteristics are different. So it cannot be solved based on divide and conquer method. There are three steps in divide and conquer algorithm. One is divide the problem into subproblems if it is large problem. Second is solve the subproblems. And the third is combine the solution of subproblems. Pictorial representation of divide and conquer method. Here problem size is n. In the next step, it is divided into two subproblems of size n by 2 each. Then solved each subproblems. Last, combine the solution of two subproblem, which is the final result. Control abstraction for divide and conquer method, or general method of divide and conquer. Here D and C is the name of algorithm. The algorithm may be binary search, max min, merge sort, quick sort, etc. P is the problem or problem size. Step 3 says if small of p, then return s of p. That means if the problem is small, then there is no need to divide the problem into small sub problems. So find the solution and return s of p. Return solution of problem p. Step 6 says if the problem is not small, problem is large, then divide p into small instances. Small p's or subproblems p1, p2, p3, etc. pk. Now we have k subproblems. Step 7 explains D and C algorithm applies to each of these k subproblem until the problem is small. It is performed in step 8. Step 8 is a recursive call the same problem or same program with P1, P2, P3, etc. Pk as arguments and combine the result of k subproblems. Another example. Here problem size is 8. First, n is divided as 2 subproblems. Now size of the 2 subproblems are 4. In next step, 2 subproblems are again divided. We get 4 subproblems of size 2 each. 4 subproblems are again divided. We get 8 subproblems with size 1. Now the problem is too small. Find the solution of each subproblem and how combine the result. Now we get 4 combined solution with size 2. These 4 solutions are processed and combined. Again we'll get 2 solutions with size 4. These 2 solutions are processed and combined. Again we'll get final solution.